Okay, this is the Algebra 2 video lesson for section 1.4, solving equations. So again, this is a review of Algebra 1, just a little bit faster. We're just going to solve equations, and then we're going to solve some word problems by writing equations. Here are the properties of equality. You kind of already know these. It's basically how to do the opposite, or basically when you want to undo something on one side, you have to do it to the other. So in order for two equations to say equal, you have to do the same thing on both sides. That's all that is saying. So let's just review these. Hopefully this comes right back to you, just like riding a bike. The way I solve these, and I like to teach you guys how to solve these, is to put tracks around your equal signs. You separate the two sides all the way down so that you know if you're doing something on one side, you're going to do it on the other side to keep them equal. And so the first thing you want to do is look for your variable. Here we're solving for x. Okay, so you want to undo everything that's happening to that x. In this case, it's 4 is being added to it. So we want to undo that by subtracting 4. If we do that on one side, we have to do it on the other. So we're going to subtract 4 from both sides. This goes to 0. So we don't write x plus 0, right? That just goes away. And in algebra, we don't write that 0, so we just are left with x on this side. X equals, and then negative 12 minus negative 4 is negative 16. And now x is alone, so that is my answer. Okay, so try this one on your own. Press pause, and then check back for the solution. I do want your answer to be simplified. So leave it as a fraction. You don't have to put it as a decimal, but do simplify your fraction. Okay, press pause. Okay, so here this is 12 times b, so the opposite of multiplying is dividing, so divide both sides by 12. You get 18 over 12, and they both have a 6 in it, so divide both numbers by 6, and you get 3 over 2. Okay, so that was just one-step equations. Let's move on to multiple step equations. Here, we're going to put our tracks around our equal sign, so we separate the two sides. Then we have to simplify each side before we can move anything around. The left side is simplified, but the right side needs to be, this 3 needs to be distributed. So let's distribute that. That becomes 3y minus 9. This equals, and this stays the same, 6y plus negative 27. Okay, and now we're going to find our variable. We have one on this side and one on the other side. So we need to move one term with our variable. We need to get our variables on the same side. So I usually like just subtracting the one that is smaller. That's not always the easiest way to do it, but in this case it is. So let's subtract 3y here from both sides, and then this becomes, this stays negative 27. This becomes plus 3y. This goes away. We don't write the 0, we just have a negative 9. Okay, and now I just have one variable here on this left side, so I'm going to undo everything on this left side. First, I'm going to get rid of this negative 27 by adding, I keep doing that, sorry. Adding 27 to this side, I have to do it to this side. This goes away, so we're left with 3y on this side, and negative 9 plus 27 is, what was it, 18. And then divide both sides by 3. And y equals 6. Okay, so just warming you up. Hopefully this all comes back and it's not too difficult. Here is one to try on your own. So press pause and then check, do this in your notes and then check back for the solution. Okay, here we get the answer is x equals negative 1. You have to distribute these both sides. Combine like terms, the 6x and this negative 6x goes away because it goes to 0. And then this becomes a negative 11, and when you divide that by 11, you get negative 1. Okay, so let's put words to these problems. So in this problem, it says flower carpets incorporate 100,000 brightly colored flowers, blah, blah, blah. Here, there's a big carpet. It has a perimeter of 200 meters. What are the dimensions of the flower carpet? Okay, so here, you can see here, the length is 3x, and the width is x. So if we're doing the perimeter, this is also 3x. And this is also x. So perimeter is going to be add up the sides, right? So 3x plus 3x plus x. And they say it's 200. So now we just have to solve for x. So combine all these like terms. 3, 4, 5, 6, 7, 8. We have 8 x's. And that equals 200. So we can divide both sides by 8 to get x alone. And 200 divided by 8 is 25. So if x is 25, let's look back to the actual question. What are the dimensions of the flower carpet? That means this is 25 meters. And then 3 times 25 is 75, so this is 75 meters. So the dimensions are 25 meters by 75 meters. Not too bad, right? Okay, so the one to do on your own says, suppose the flower carpet would have a perimeter of 320 meters. What would the dimensions of the flower carpet be? So they're just changing the perimeter here. So try this on your own, press pause, and then check back for the solutions. Okay, so for this one, this all stayed the same. This number just changed. So this stayed 8x. And then when you divide 320 by 8, you get 40. And then 3 times 40 is 120. So 40 meters by 120 meters. Okay, and then the last thing we're going to work on is equations don't always have an answer. When they say solve for it, most of the time it's going to be there's going to be just one answer. So that would be a so in this problem it's asking us to say if the equation is always, sometimes, or never true. So most of the times in algebra we're going to be dealing with sometimes. When you can solve for the variable, the answer is sometimes. It's when that variable is that specific number. But there are cases where there are identities where they're just, if there's two things, if you just get like x equals x or 1 equals 1, and you can't solve for a variable, if a variable cancels, that would always be true. And then if you get a number, like if you end up solving it and the variables cancel and you get like 1 equals 0, which is never true, then that would be never true. And so here's examples of that. This first one, let's go to solve it. Just like we would solve anything. Let's simplify 11 minus 7. Is 4, so this is 3x plus 4, and then this is 6x minus 3x. This is 3x plus 5. Okay, so now when we go to subtract 3x from both sides to get x alone, they both cancel. See what happened there? And we're left with 4 equals 5, which is never true. So 4 does not need, so there's nothing you can, there is nothing you can plug in for x here that would make this equation true. Okay, actually, you would just write never, but that's fine. Okay, and let's look at this example here. Simplify this becomes 4x plus 5 because we combine these two. We combine these two, and this is 4x plus 5. We can see these are the same things. When we go to subtract the 4x from both sides, they cancel, and we get 5 equals 5, which is always true. So this is going to be always true. So if you, no matter what number you plug in here, x can be literally any number, and it will be true. Okay, so that's never and always. And your homework, I think just sometimes comes up. So one of these examples should be sometimes. If you get an answer like x equals a number, that's sometimes. If you get two numbers that don't equal each other, saying they equal, it's never. If you get two numbers that equal each other, it's always. Okay, so try these two on your own after you push pause, and then check your work, and then we'll be done. Okay, so we didn't even get a sometimes example. All the rest of these on the in the section are sometimes. If you get an answer. In this case, we have two numbers that don't equal each other, so it's never true. We have two numbers that always equal each other, so it's always true. Okay, so time to practice. Enjoy.